Let's look at some more Bernoulli trial questions. Jimmy fires an arrow. He has a 1/4 chance of hitting. So we call probability of success 1/4. He fires 10 arrows. Find the probability to the nearest percentage that he hits the target the first 3 times, but misses the rest. Now this is actually quite specific. This is, we'll call H, or we'll call success and failure. We'll say hit, that's success, 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 and then followed by 3, 4, 5, 6, 7 failures. So there's no mixing up of where the successes are. So this is going to be 1/4 to the power of 3 by 3/4, the probability of failure to the power of 7. Which is a tiny amount, so we can actually round, this would be rounded off to 0% if we were looking at the laws of probability. Nearly an impossible thing that can happen, but it can happen. 21 out of every 10,000 times, or 2 out of every 1,000 times, which doesn't give it really much of a value out of 100 for percentage terms. So he hits the target exactly 3 times, so 3 successes out of 10 arrows. The probability of success to the number of successes, and the probability of failure to the number of failures. And that's going to be 0.252, 25.2%, which is 25%. And then at least once, but these at least questions, always identify there's a quicker way to do them. At least once is 1 minus the probability of none. So we get the chance of not hitting the target at all. You don't need these first 2 in, but just put them in to keep consistent. There's going to be 3/4 to the power of 10 failures, and that gives 0.0563. So 1 minus 0.0563 gives 0.9437, so 94% in percentage terms. So we look at question 15. Susan rings her mother. The chance that her mother will answer the phone, 3/5. So we call the probability of success 0.6. So the probability of failure in this Bernoulli trial, 0.4. Susan rings her mother every day for a week, so we've 7 to choose from, 2 significant figures. She answers exactly 4 times. So the 7 days, 7 choose 4. So success to the power of 4 by failure to the power of 3 will give us exactly 4 times. And that's 0.290, so just 0.29. Will give us 2 significant figures. That's number 1. 6 or more. So the probability is 6 or the probability is 7. We'll add them together. So probability is 6. 7 choose 6 by 0.6 to the power of 6 by 0.4 to the power of 1. And 7 choose 7 by 0.6 to the power of 7 by 0.4 to the power of 0. If you want to include it to keep the same pattern each time, you'll never forget how to do them if you keep the same pattern. So this is going to give 0.1306. We just say 0.13 because it's the significant figures. This was 0.0279, 0.03 give us 0.16 for 6 or more. And then on Monday and Tuesday only is a very specific one again. So success on Monday, success on Tuesday, and 5 failures. So specific order. So we have success 0.6 to the power of 2 by 0.4 to the power of 5. And that's going to give 0.0 doesn't ask, 0.3, not 0.37. So we leave it at that for this one so we can see the answer. 16. An insurance firm calculates that a client has 1 in 20 chance of having one or more accidents. So we'll say the probability of success, and it's an accident, so not ideal language, but it's 1 over 20. The probability of failure we'll take as the 19 over 20. We can reverse them around if we need to. If his client is insured for 10 consecutive years, find the probability no accidents. So 10 years, no accidents. So you're saying he's had no successes. So 1 over 20, no accidents to the power of 0. But we should probably have reversed these around. 19 over 20 to the power of 10, so it's just 19 to the power of 10 over 20 to the power of 10. And that rounds off to be 0.5987. So 59.87% chance he will have an accident in more than 1 year. So that more than 1 year would not include, so that's the probability of more than 1 year, so 2 plus. So we need the probability of none and the probability of 1. The rest of them will be 2 or more. So we have the probability of none, the probability of 1 over 20 to the power of 1, 19 over 20 to the power of 9. Be 0.3151, and adding those together, we're just taking them both away from 1. These two are going to give me 90 and then 1.38, 91.38, and 1 minus 0.9138 is going to give me, it's going to give me 862, 0.0862. And that's the probability of an accident in more than 1 year.